Welcome to a brief introduction on meteorology. This slide provides a quick overview of navigating through the remainder of the module. The buttons to the left of the play bar allow for playing and pausing a slide, forwarding to the next slide, or reversing to the previous. The progress bar shows advancement through each slide and the module as a whole. To the right of the play bar are several useful buttons. From left to right are the volume control and the closed captioning toggle, which allows you to view the narration text as it is spoken. The TOC button displays the table of contents, which allows you to quickly move from one section of the module to another. Slides not yet visited will be grayed out. The Continue button on the bottom right of the screen advances you to the next slide or section. This concludes the navigation overview. In this short module, we will be discussing the topic of meteorology and some of its more interesting aspects. The module begins with the definition of the term and a quick overview of meteorology's vital importance. You will then review the three primary components of meteorology. The next section delves more deeply into one of meteorology's primary aspects, that of cloud formations and types. Lastly, we'll discuss the many web-based resources available for those interested in meteorology. At the end of each section, you'll be given 2 short questions as review of the material just covered. Please click the Continue button now. Meteorology is the study of the atmosphere, atmospheric phenomena, and atmospheric effects on our weather. The atmosphere is the layer of gases that surrounds a planet and is a key element of its physical environment. Meteorologists use scientific principles to observe, explain, and forecast our weather. They often focus their research on operational weather forecasting, which is of the greatest use to most people. Atmospheric conditions both at the Earth's surface and above are measured from a variety of sources: weather stations, ships, buoys, aircraft, radar, weather balloons, and satellites. Weather data is collected and transmitted to centers throughout the world to produce comprehensive computer analyses of global weather. Almost all social, industrial, agricultural, commercial, and transportation activities are directly or indirectly affected by weather and climate. The atmosphere directly affects and sustains human, animal, and insect life during every stage of growth and development. As such, meteorological data impacts every aspect of life on our planet. Safe navigation at sea depends on advanced knowledge of potentially adverse weather, to include ocean waves, high winds, and cyclonic storms. Aviators are specifically interested in atmospheric conditions such as wind speed and direction, lightning, and visibility. Many industries depend on agricultural produce for their raw material and select their resource sites accordingly with key consideration of local weather and climate patterns. When building homes and businesses, weather information impacts the design of windows, doors, and roofing types. Meteorology is divided into 3 primary components of study, which, when combined, form a complete picture of the atmosphere and its expected near-term effects. These components include air temperature, humidity, and precipitation. Press each of the images for more information. When done, select the Continue to Check on Learning button to review the content. Temperatures reflect the relative amount of heat present in a scale that has meaning for our physical world. Free air does not have sun shining on it directly and strives to capture the average temperature reasonably experienced in that location. Hiking in the mountains, you've probably noticed that the temperature falls as you gain altitude. That's the lapse rate. Given a standard situation, the temperature goes down 2 degrees Celsius per 1,000 feet of altitude. Humidity describes the amount of water vapor content in the air. Humidity is measured with a value known as the dew point. In general, higher temperatures result in lower density air, and therefore more space for water vapor. Relative humidity is a ratio reflecting the amount of water vapor present compared to the theoretical maximum amount air at a certain temperature can hold when saturated. When the air contains all the water vapor it can hold at its temperature, the relative humidity is 100%. A relative humidity of 50% indicates that the air contains half of the water vapor it can hold at its temperature. Water particles form in the atmosphere and fall. Precipitation amounts and types have a profound impact on flight safety. Pilots must be aware of these many effects, including reduced visibility, icing, and takeoff and landing performance. Precipitation can take one of several forms, to include drizzle, rain, hail, and snow. Clouds are, essentially, visible condensed moisture. Saturation-producing processes create cloud formations in the atmosphere. There exist three major types of clouds. These are cumulus, which have a heaped or piled look to them, stratus, which forms in sheet-like layers, and nimbus, which are rain-bearing clouds. Furthermore, clouds are classified based on their atmospheric height above ground level, or AGL. These three classifications are high, middle, and low. The high cloud group consists of cirrus, cirrocumulus, and cirrostratus clouds. The base of these clouds starts at 20,000 feet above ground level or higher. Cirrus clouds may indicate approaching changes in the weather. The middle cloud group consists of altocumulus and altostratus. Bases of middle clouds start as low as 6,500 feet, and tops can range as high as 20,000 feet. Altocumulus rarely produces precipitation, but altostratus usually indicates the proximity of unfavorable weather and precipitation. The low cloud group consists of stratus, stratocumulus, and nimbostratus. Bases of low clouds can start near the surface, with tops extending to 6,500 feet or more above the terrain. Combined with lower temperatures, these clouds raise the probability of icing effects. Roll your mouse over each of the cloud type identifiers for a high-quality image. Press Continue when ready to review the material. The Internet provides a vast amount of freely accessible meteorological information for everyone, from the novice to the experienced weather watcher. While there exists any number of excellent Internet resources, two of the more frequently visited are weather.com and Aviation Weather. For the layperson and pilot respectively, they provide a quick reference point for information necessary to their visitors. Select each of the listed sites for a quick tutorial. When done, select the Continue button for module summary. Weather.com is easily accessed from your browser by typing it into the address line. Once there, you can immediately view information relevant to your default location. If you would like to search for another location's weather data, simply type the name into the search box. In looking at Flagstaff's current information, we see the temperature, sky condition, winds, humidity, etc. To the right is a quick summary of the day and evening highs, lows, and expected conditions. If you would like an extended forecast, you could select the 5-day summary below, which, when clicked, pulls up similar information going out for 5 calendar days. Aviation Weather is a very useful site for accessing a vast amount of information relevant to those who are planning on taking to the air. The home page defaults to your last search location. Just above the maps are links to pilot-specific reports. There are a wide variety of forecasts to choose from, to include the winds and temperatures map. When selected, it displays the wind direction, shown by the long bar, and strength shown by the number of vanes, as well as the temperature at 30,000 feet. Under Observations, you can choose to view either the radar image of the chosen region or the satellite map, both of which run for a short time. Pilots may be interested in the many tools available, to include briefings, links, and planning options. In this short module, we discuss some of meteorology's more interesting aspects. We define the term and provided a quick overview of its importance in our lives. We reviewed the three primary components of meteorology and then discussed in detail the various cloud formations and types. Lastly, we discussed and viewed demonstrations of two meteorology websites. Thank you for your attention.